Hello, yes, and welcome to our Objective 4 notes. Now, Objective 4 says, I can simplify an algebraic expression and label components of my expression. So today we're going to focus on simplifying the algebraic expressions. All right, so whenever we want to simplify algebraic expressions, we want to combine like terms, and that's something we've probably heard before. Combining like terms is relevant all around mathematics. So like terms are terms that have the same variable and the same degree. Now, what is the degree? The degree is the exponent of the variables in a single term. So when we're combining these, we're looking for terms that have the same variables, and if they have exponents, variables with the same exponents as well. Now for today, mostly we'll just be looking at variables. I don't think we'll get into degree too much, but it's important to know as we move forward. So let's look at some problems where we're going to combine some like terms, simplify these expressions. All right, problem set 1, letter A here, 3x minus 5y plus 2x minus 3 times the x plus 2y, which is in parentheses. All right, so let's combine, well, let's distribute this first. That'd probably be a good first step. So we'll have 3x minus 5y plus 2x. Negative 3 times x would be negative 3x. Negative 3 times 2y would be negative 6y. So looking right here, I see right away, I have 3x, I have negative 3x. So 3x minus 3x is 0, so I'm left with 2x. And then I have minus 5y minus 6y. Negative 5 minus 6 is negative 11. So I'd have negative 11y. And I know I'm fully simplified when I only have one term with each variable in it. All right, let's look at letter B. 7z minus 1/2, the quantity 6x minus 8y plus 10 minus 3x plus y. All right, so 1/2, multiplying by 1/2 is the same as dividing by 2. So I'm going to divide each of these by 2. So I'm going to have 7z, and really it's divided by negative 2. So I'll have negative 3x, negative 1/2 times negative 8y would be positive 4y. Negative 1/2 times negative 2 would be minus 5. And then minus 3x and plus y. All right, so let's combine some like terms here. So we have negative 3x and negative 3x. That will give me negative 6x. We have 4y plus y, that will give me 5y. We have 7z, and then we have minus 5. And that would be our simplified terms. There we go. All right, looking at letter C, 6/3 x minus 8/2 y plus 7x minus the quantity y minus 2x. Well, what's 6 divided by 3? Just 2, right? And what's 8 divided by 4? Or 8 divided by 2? It's 4. So I can simplify those real quick. Now distribute this negative, so I'll have negative y, I'll have positive 2x. So I have 2x plus 2x, that'll give me 4x. I also have this 7x here, so that means it's 11x. And then I have negative 4y minus y, that'll give me negative 5y. So I'll have 11x minus 5y as my solution. Fantastic. All right. Let's scroll down a little bit here. Looking at letter D, 5c minus 2a plus 3 times the quantity c minus a. So first thing is we're going to distribute that 3. So I'll have 5c minus 2a plus 3c minus 3a. All right, 5c plus 3c is 8c. Negative 2a minus 3a is negative 5a. And look at that. I think we're done. Not bad, not bad, not bad. Letter E, we have to distribute a bunch here, all right? So we got to distribute this 4 into everything. And then we also need to distribute this negative 3 into everything. All right, so let's start with distributing the 4. So 4 times x would be 4x. 4 times negative 2y would be negative 8y. 4 times 5z would be 20z. Then I'm minus 3z. And negative 3 times 2 is negative 6. All right. So let's see what we got here. Well, this is my only x term. This is my only y term. So I'm going to have 4x minus 8y. 20z minus 3z. That'll give me 17z. And then minus 6. And I'm done there. There you go. Not bad, not bad, not bad. Looking at letter F, 9/3 times the quantity 2x minus y plus 4 minus the quantity 5x minus 2. Well, what's 9 divided by 3? 9 divided by 3 is 3. So let's rewrite that right here before this gets too more complicated. And let's go ahead and distribute this negative. So I'm going to have negative 5x, I'm going to have positive 2, because if I'm subtracting a negative, I'm really adding that positive. So 3 times 2x is 6x, 3 times negative y is negative 3y, 3 times 4 is 12, and I have minus 5x plus 2. And now combine our like terms. I have 6x minus 5x, that leaves me with 1x. I have minus 3y, and I have 12 plus 2, which is 14. There we go. All right, how are we doing? If you have any questions, go ahead and raise your hand. Otherwise, why don't you try G, H, and J on your own? Try these next 3. Go ahead and pause the video now, and then we'll check those together, all right? All right, let's see how we did. Oh, excuse me there. Let's see how we did here with letter G. 12x minus 5y minus 3. I see I'm going to have to distribute that negative 3. So let's do that first. So I got 12x minus 5y minus 3z minus 6y, and then plus z. From here I can combine my terms. 12x is the only one I have there. Negative 5y minus 6y would be negative 11y. And then negative 3z plus z would give me negative 2z. Not bad, not bad, not bad. All right, looking at letter H. 8c minus 4a plus 3, and I'm going to multiply that by the quantity a minus 3c plus 5. So I'll have 8c minus 4a plus 3a minus 9c plus 15. All right. I don't know what that's doing. There we go. All right, so 8c plus 3a is, 8c plus minus 9c would be negative c. Negative 4a plus 3a would be negative a. And then I have positive 15. And if you wanted to put it in alphabetical order, you could. Definitely don't need to, though. So we have negative a minus c plus 15. That'd be our simplified form there. All right, this last one, we don't have any distributing to do. We can just right away combine some like terms. So we have 4x minus x, so that'll give me 3x. We have negative 3y plus 2y, so that'll give me negative 1y. And we have 2z minus 3z, that'll give me negative z. So I got 3x minus y minus z. Not bad at all. All right. How'd we do? How'd we do? If you did good, let's move on to KLM. If not, go ahead and raise your hand and we can figure out what's going on here. All right. So if you're ready to move on, go ahead and try K, L, and M on your own. Go ahead and pause the video, give those a shot, and then we'll check them together. All right, let's check how we did with K, L, and M. So looking at letter K here, 4 over 2 is just 2. So this is 2 times 1/2 x minus 3/2 y plus 5x minus 7y. So 2 times 1/2 is just 1, so this would just be x. And 2 times negative 3/2 would be negative 3, so that'd be negative 3y plus 5x minus 7y. Combine our like terms, we'd have 6x minus 10y. There we go. Very nice. Looking at letter L, got some distributing to do here. So I'm going to distribute this 2 into everything. So we got 4r minus 10t plus 12. And then we got the negative 3 that we need to distribute. So we have negative 3r minus 15 minus 12t. So 4r minus 3r is just r. Negative 10t minus 12t is negative 22t. And 12 minus 15 is negative 3. So I got r minus 22t minus 3. What just occurred there? Wow. I have no idea how that happened. Let's try to erase that. Crazy. I apologize for that. That's the first time that's occurred. That's alright. Alright. R minus 22t minus 3. Maybe they just didn't want us to get to this last one. They're enjoying it too much. That's alright. Alright. So, distributing 4/3. So 4/3 times 3. 4 times 3 is 12. 12 divided by 3 is 4. So this would be 4x. 4 times negative 9 really is negative 36. Negative 36 divided by 3 is negative 12. So that'd be negative 12y. Plus 5. Distribute the negative 2. So I have negative 2x minus 2y. Right? Because we got to take that negative 2 into everything in those parentheses. So with that being said, we got 4x minus 2x. That'll leave me with 2x. We have negative 12y minus 2y. That'll leave me with negative 14y. And then we have plus 5. And that would be my simplified form. Awesome. How'd we do? All right, if you have any questions, please raise your hand now. Otherwise, we're going to keep going and we're going to talk about parts of an algebraic expression. We're going to define a couple terms. First, here's an example of an algebraic expression, 5x minus 3. That's something that we'd see. It is a binomial, which means it has two terms. It has a variable x, the coefficient's 5, the constant's negative 3. Let's define what all of that means. Now, the variable is the unknown value in an expression. Oh goodness, spelling is hard. Unknown value in an expression. You know, the variable is what can change, what we don't know. It's a value, but we don't know that value, or we're not limiting that value. The constant, however, is a known value. A known value. It does not change. All right. So, for example, negative 3. Negative 3, we know the value of negative 3. It's negative 3. That's not going to change as the variable change. The coefficient is the multiplier of a variable, and it's the number in front of the variable. You know, we're saying 5 times this variable in our expression up above. And then the leading coefficient is the coefficient, and I know I shouldn't probably use a word in the expression, the coefficient of the term with the highest degree. The highest degree. So we defined degree earlier. Degree, remember, is the exponent of a variable. So we're going to talk about those as we look at some examples here. So let's look at problem set 2. State the desired information for the following expressions. All right, so we have this polynomial, 3x to the third minus 2x squared plus 6x minus 5. The leading coefficient in this one is 3, because x to the third is the term with the highest degree, and 3 is the coefficient. The constant in this one, remember the value that doesn't have a variable, it doesn't change, is negative 5. The variables that we're dealing with in this one are just x. The coefficients, so this is where we list all the coefficients we have. So we have 3, we have negative 2, and we have 6. 3, negative 2, 6. How many terms do we have? Now, terms is just what's being added or subtracted together. We add or subtract 1, 2, 3, 4. 4 terms here. All right, let's look at B, the leading coefficient. Well, the term with the highest degree is x to the 6th. It doesn't have a coefficient there, but we know then that means 1 is what we're multiplying by up front. All right, the constant, there's no constant here. All right, there's everything that we're adding or subtracting has a variable. All right, so the constant there is none. The variable is x. The coefficients are 1, 4, and negative 12. How many terms does this have? Well, we have 3 things that are being added or subtracted together, so there are 3 terms here. Looking at letter C, a leading coefficient, well, x squared is our term with the highest degree, and negative 2 is what's in front of that, so negative 2 is our leading coefficient. Our constant in this one, 102, is being added without a variable. Our variables that we're dealing with are x. Our total coefficients, we have negative 2 and 9. Remember, 102 isn't a coefficient because it is the constant. And then the number of terms we have for this one are 3. All right. If you have any questions, raise your hand, let me know. Otherwise, why don't you go ahead and try D, E, and F on your own, and then we'll go through those together. All right, let's see how we did here. So looking at letter D, our leading coefficient would be 3. Our constant would be negative 14. Our variable is x. Our coefficient, we only have 1. It's just 3. The number of terms, 2. That leading term, and then our constant. All right, our leading coefficient at E, we have that negative in front here, so it would be negative 1. Our constant is 31. Variables we're dealing with in this one is x. Coefficients, we'd have negative 1 and negative 9. And the number of terms, this would have 3 terms. Now looking at letter F, my leading coefficient here, let's see, we have x to the 5th, that's our degree with the highest term. So 21, or a term with the highest degree, sorry. Our constant here would be negative 15. Our variables we're dealing with is x. Coefficients, we got 21, we got 7, and we got 9. And this one has 4 terms. All right. How do we do? Raise your hand if we're still struggling. I want to step it up a level though. So looking at these problems here, write an algebraic expression that satisfies the given information. I want you guys to try this on your own first. All right, so go ahead and try A, B, and C, or at least try A, and then let's check to see how we did it together. All right. I'll give you a little bit of time. Go ahead and pause the video. Try to write expressions that satisfy the given information, and then we'll check. All right, so it's possible here to have a lot of different answers that are correct. The important thing that we're going to look at is make sure that we've satisfied all of this information for these. So looking at letter A, 3 terms, leading coefficient of negative 2, highest degree of 4, and a constant of 11. So what this tells me here is that I'm going to have 3 terms. So I know I'm going to have something plus something plus something. My leading coefficient is negative 2 and my highest degree is 4. So that tells me right away that I'm going to have a term that's like negative 2x to the 4th. Because that way my leading coefficient is negative 2 and my highest degree is 4. Then I could have anything here. I need another term before my constant, which will be my last term. That's 11. So you could say x to the 3rd. You could say x squared. You could even say 7x. Right there, and that would work. Let's check it. It has 3 terms. The leading coefficient is negative 2. The highest degree is 4, and it has a constant of 11. So we nailed it. All right, let's check out letter B here. 5 terms, variable of x, highest degree of 6, leading coefficient of 1, and a constant of negative 29. So the highest degree of 6 and a leading coefficient of 1 tells me that my first term is going to be x to the 6th. So that takes care of this one and this one. Let's see, 5 terms before a constant of negative 29. So let's do plus 2x to the 5th minus 3x to the 3rd plus 4x squared. And then I need a constant of negative 29. So let's check to see, make sure this checks out. It has 5 terms, 1, 2, 3, 4, 5, good. Variable of x, indeed. And then we already know about these two. Highest degree of 6, yes. Leading coefficient of 1, yes. And a constant of negative 29, yes. Awesome. All right. Last one, C. 2 terms, highest degree of 3, no constant. All right. So a binomial here. That means a polynomial with 2 terms, highest degree of 3, no constant. So we can say x to the 3rd minus 4x squared. Highest degree of 3. 2 terms, no constant, nailed it. All right, and that's where we're going to stop today. Let me know if you have any questions. Otherwise, raise your hand and I'll get those practice problems. You'll be able to do problem set 1 and 2, and then we'll do problem set 3 tomorrow where we'll look at some word problems over all of this. All right, let me know if you have any questions and I'll see you next time.